Okay, so in the last section we talked about solving right triangles. In this section we're going to talk about solving oblique triangles. Oblique just means non-right. Okay, so solving oblique triangles is a little bit trickier, um, but we can solve oblique triangles by appealing to two facts that you may remember from your trig days, and they are the law of sines and the law of cosines, right? So this is the law of sines and this is the law of cosines. And they help us to solve oblique triangles. Now, I'm not going to hammer out this would be something that you would do in a trig class, but you should be able to convince yourself or maybe remind yourself of the following. And to help you do so, here's an online textbook that you can access, and look at these pages of that textbook to convince yourself of the following facts. But when you go to solve an oblique triangle, you need at least 3 pieces of information, right? So in total, there are 6 pieces of information on a triangle, the 3 sides and the 3 angles, okay? You need at least 3 of those in order to be able to solve the triangle. So what kinds of information could you be given? Well, you could be given an angle, well, you could be given 2 angles and then a side that's in between them, or you could be given 2 angles and then a side not in between them. You could be given 2 sides and an angle that's between them. You could be given 3 sides. In each of those cases, the triangle that's being described to you either doesn't exist, right? It's either impossible, and you'll know that you have an impossible triangle if in the course of solving the triangle you end up with some kind of contradiction like sine A equals 1.5 or something, which isn't possible, right? Because sine, the largest sine can never be is 1. So you'll know if they're describing an impossible triangle if you arrive at some kind of contradiction. But if the triangle is not impossible, if it is a possible triangle, then you're going to get exactly 1 solution when you're dealing with this kind of information that you're given. Another possibility is that you could be given 2 sides and then an angle not between them, right? So side-side angle. Now this one is called the ambiguous case because side-side angle does not guarantee a unique triangle, okay? But there can be at most 2 triangles with the given information, right? That fit the bill. So again, side-side angle, just like the other ones, it could be describing a triangle that doesn't exist. Or it could be describing just 1 triangle that exists, or it could be describing 2 triangles that exist, that fit the description given. So it's different from these first 4 cases in that, well, it's ambiguous, right? It could be describing 2 triangles, whereas these ones are describing just one triangle, assuming, of course, that the description matches with a triangle at all. And then one last piece of information you could be given is you could just be given 3 angles. And for that matter, you might just be given 2 angles, right? Because if you're given 2 angles, you could find the 3rd angle. The problem is that there's no way to figure out what the sides are. If you're only given the angles of a triangle, you can't figure out what the sides are. So you need to know what at least one side is. Angle can guarantee that a triangle is similar to the one that's being described, but it can't find a congruent triangle to the one being described. Or rather, maybe a better way to say that is that there are infinitely many triangles that will fit this description, okay? Assuming that the angles add up to be 180 degrees. There are infinitely many triangles that will fit that description. So these ones don't have a unique solution at all. So we really don't talk about solving angle triangles because it's not possible. But the other kinds of triangles we can solve. Now, here's the strategy for solving these kinds of triangles. If you're given angle side angle, angle side, or side side angle, then we start off by using the law of sines, right? Which is this first identity down here. Okay, so we start off by using the law of sines to solve for either a missing side or a missing angle, and then we can kind of go from there, right? So that's if we're given angle side angle, angle side, or side side angle. Remember that side-side angle is the ambiguous case, though, and we'll talk about how to deal with the ambiguous case in a second with a couple of examples. Now, if on the other hand we're given side angle side or side 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 information, then we start off by using the law of cosines, which is this one down here. The law of cosines is really just, it's a generalization of the Pythagorean theorem, okay? And the reason I say that is because if you look at this last statement down here, right, it says c squared equals a squared plus b squared, which is the Pythagorean theorem, but then it just has this extra piece of information, right, minus 2ab cosine c. Well, if c is 90 degrees so that you have a right triangle, then cosine of 90 degrees, right, cosine of 90 degrees is 0. And so this whole last term just disappears, and you end up with c squared equals a squared plus b squared, just like the Pythagorean theorem says. So the law of cosines is really just an extension of the Pythagorean theorem that we can use on any triangle, okay? And that's what's nice about it. The Pythagorean theorem you can only use on right triangles, but you can use law of cosines on any triangle, right? Same thing with law of sines, but the law of cosines is the extension of the Pythagorean theorem that's useful for us. Okay, so angle, side, angle, 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 side, or side, side, angle, we use law of sines. Side, angle, side, or side, 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 we use law of cosines. Okay, so let me run you through several examples. Okay, so this one says solve triangle ABC if B equals little b equals 4, capital B equals 40 degrees, and capital C equals 75 degrees. And I'm telling us here that this is an angle, angle, side triangle. To see that, I think it's useful to draw a picture. I mean, we have no idea what this triangle really looks like, but it doesn't really matter. Just give yourself some generic triangle and start labeling stuff. It'll help you to keep track of what you're looking for and all of that. So B, it says, is 40 degrees. C, it says, is 75 degrees. And then little b, it says, is 4. This could be 4 inches or 4 yards or whatever. It doesn't matter. Okay, 4. All right. So we can use law of sines. Well, for one thing, we could just use the fact that the sum of the angles of the triangle has to be 180 degrees. So we could figure out angle A pretty easily. Let's maybe start there. Let's start there. So we're going to say A is 180 degrees minus 40 degrees minus 75 degrees. So that's 65 degrees. Okay, so we've got A. Now, what about these sides here, right? We can't use a trig function directly. Like, we can't say something like sine 75 equals this side over that side or whatever, because this is not a right triangle, okay? So, so we can't use a trig function directly. But what we can do is we can use the law of sines. We can say, well, we can say sine 40 over 4, right? That's sine b over b equals, well, I know this angle, so I could do c over, or sorry, I could do sine c over c. Actually, maybe I'll do this the other way around. So I'll say 40. So I'll do a over sine a, or sorry, b over sine b equals, let's do c over sine c. See, this one we can solve for the letter, for side c, for sure, right? In fact, all I need to do is multiply through by sine 75 degrees. Okay. And then I can use my calculator to figure out how much that is. So we've got 4 sine 75 divided by sine 40. Make sure you're in degree mode. That comes out to about 6.01. Okay. I can do the same thing with this missing side because I know angle A, right? So I can say b over sine b equals a over sine A, which we found out was 65 degrees just a second ago. So this would imply then that A equals 4 sine 65 divided by sine 40. And let's see about how much that is. I'm just going to change the 75 degrees to 65 degrees. That's about 5.64. Okay, so there we go. We've got A, angle A we've got, and then we've got sides A and C. And that does it, right? So that's how we use law of sines when you're dealing with something like an angle side situation. But let's look at some side angle situations. Since this is the ambiguous case, it's worthwhile to look at several solutions. And here I'm giving us a hint that this is going to be a side angle with two solutions. But if you didn't know that going into the problem, here's how you would find out. So first of all, you draw a picture, label the sides and the angles. Okay, so I think that will do as far as labeling is concerned. And you can see again that the law of sines is going to be useful for us here. By the way, this is a side angle. We've got side, a side, and then an angle not in between the sides, right? So it's not side, angle, side, it's a side angle. Okay, but right away we can see law of sines is going to be helpful because we can do something like sine B over B equals sine C over C, and then solve for angle C, right? So that's what we'll do. Okay, so then we can multiply by 150. And then we can take sine inverse of both sides. And let's see what we get. So we're going to do sine inverse 150 sine 32 divided by 100. That comes out to about 52.6. Now, here's how you check for the ambiguous case. Okay, what's ambiguous is that there could potentially be two different values for C that will work with this triangle. And so the way that we check it is, what we're going to do is we're going to look at, we're going to leave C the way it is, right? That's going to be case one. So maybe I'll say case one is that C is approximately 52.6 degrees. Case two is going to be C is approximately 180 degrees minus 52.6 degrees. Okay, that's the other possibility for C. So let's see, 180 minus 52.6 is 127.4. So the other possibility is that C is about 127.4 degrees. Now, how do we check to see if this, so case one is always going to be valid, okay? Case one is always going to be valid. But case two, sometimes it is and sometimes it's not. And how do we check to see if case two is valid? Well, if we add this angle to the angle that we already know, and we get something more than 180, well, then we know that case two cannot possibly give us a valid triangle, right? But if we add this to the angle that we already know and we get something less than 180, well, then case two might, then case two is a valid case, right? It gives us another valid possibility, okay? In this case, 32 plus 127.4 is going to be less than 180, right? So I'm just going to check, right? 127.4 degrees plus 32 degrees equals 159.4 degrees, I think. Yeah, which is less than 180. Okay, so case 2 could give us a perfectly good triangle. Right, so we have these two competing cases, right? So on the one hand, C could be 52.6 degrees. On the other hand, C could be 127.4 degrees, right? So we're going to give both solutions, right? We're going to look at both possibilities. Okay, so for case 1, if we take C to be 52.6, then that means A is going to be 180 minus 32 minus 52.6. Well, it's going to be approximately this amount, I guess, since C is only approximately 52.6. But this would equal 95.4 degrees, okay? So we've solved for C, we've solved for A. The only thing we have left to solve for is side A over here, which we'll do in a second. For case 2, if C is 127.4, then that would mean A would be approximately 180 minus 32 minus 127.4. That's 20.6. Okay, so that's the other possibility. Okay, and then the last thing we have to do is solve for side A, and we'll do that again using law of sines. You can't use Pythagorean theorem because this is not a right triangle. You could use law of cosines at this point. You could use law of cosines to solve for the missing side for sure. But I'm just going to use law of sines because I think it's a little bit easier. So I'm going to say, A over sine A, which in case 1 I'm saying is 95.4 degrees, equals, let's use B again, equals B over sine B. And that would imply, I'm going to run out of space actually, but that would imply that A is equal to 100 sine 95.4 degrees over sine of 32 degrees. Let's see how much that is. That's about 187.9. Okay, so there's one possibility, right? That C equals 52.6, A equals 95.4, and side A equals 187.9. The other possibility, so again, we're going to say A over sine A, 20.6, equals B over sine B, and that would imply that A is equal to 100 sine 20.6 degrees divided by sine 32 degrees. So I'm going to change the 95.4 to a 20.6. And that gives me about 66.4. Okay, so there's the other possibility. Okay. So that's that, right? So that's how you deal with the ambiguous case. Now, as we said on the previous page, the ambiguous case does not always give us two valid solutions. So let's look at another example of the ambiguous case. This is another ambiguous case, but it only has one solution. And again, you only have to check for the ambiguous case when you're given side angle. If you're given any other information, side, angle, side angle, or whatever, right? Those are not ambiguous cases. It's only when you have the side angle case that you have to check for this possibility that there might be a second triangle that fits the bill. So let's do that with this one and see why we only end up with one solution here. Okay. So again, I'm going to start off drawing a picture. So I'm told C is 40 degrees. I'm told little c is 20. I'm told little a is 15. So definitely a side-side angle. And we start off the same way, right? We're going to say sine 40 degrees over 20 equals sine of A over 15. And that means that sine A is going to be 15 sine 40 over 20, which means that A is going to be sine inverse of 15 sine 40 over 20. Let's see about how much that is. Sine inverse of 15 sine 40 divided by 20 is about 28.8. Okay, so that is case one, right? So case one is that A is about 28.8 degrees. Case two is that A is 180 degrees minus 28.8 degrees. Or approximately, I should say. 150. Okay. Now we have to check this, right? If we add this to the angle that we were originally given of 40 degrees, we're going to get 191.2 degrees, which is more than 180 degrees. So clearly this case can't hold up, right? If we say, so our check here, we say 151.2 degrees plus the 40 degrees that we were given for angle C equals 191.2 degrees, which is greater than 180. And that tells us that case two does not give us the valid triangle. So in this, so case one is the only valid triangle that we're going to get out of the description that we were given. Okay, so then we finish up with case one, right? We found this angle. Let's find angle B, right? So angle B is going to be approximately 180 minus 40 minus 28.8. Which is 111.2. Okay. So I've got this one now, right? And now the only thing I have left to find is side B. So I'm going to say B over sine B equals, well, let's use C over sine C. So C over sine C. That's going to mean that B is equal to 20 sine 111.2 degrees divided by sine 40 degrees. So 20 sine 111.2 the right